let's see if your answers agree with mine. Oh, good thing. The lowest scale of measurement, number 1. Nominal, nice. Number 2, the naming level. Nominal again, very nice. Number 3, which is the rank order. Ordinal, very nice. Number 4, which 2 indicate amount. Interval and ratio. Interval and ratio. Why doesn't ordinal indicate amount?
Because it's not the things aren't equal.
Things aren't equally spaced. It's just a ranking. It's not telling us how much. It's just telling us. Good job. Number 5. Which one has the absolute 0? Ratio. Nice. Number 6. You're measuring weight. Ratio. Because you can't weigh 0. Nice. Number 7. You're ranking your employees. Well, the key word is rank, so that must be ordinal. Nice. Number 8, you're naming the countries. So the key is naming. Nominal. Right. 9, you memorize what? Or to remember this, the little phrase it said? No oil in rivers. Nominal, ordinal, interval, and ratio. No oil in rivers. Show you where that is. See the no oil in rivers, so you can remember nominal, ordinal, interval, and ratio. Cool? Did I skip one? 10. Right, you haven't gotten to 10 yet? Yes. Number 10, what is between ordinal and ratio?
Interval.
Yes, question.
You said for number 5 and 6 are both ratio, correct?
Yes.
So how, because I thought ratio, like because it starts with 0. Is that one?
Because the absolute 0 describes a 0 that means absence of the variable.
Okay, that makes sense. I thought you were saying that it could equal 0.
Right.
Okay.
Very nice question. So she was asking, why is 6 ratio? Absolute 0 is the type of 0 that means absence, not the type that can be recorded as a score. I'm now going to Module 4 again. And I'm looking at the correlation coefficient PowerPoint. It's under the correlation coefficient handout. Line up the PowerPoint. That's it. So you just learned about Mr. Spearman and Mr. Pearson, who created statistics that allow us to measure relationships. As humans, as behavioral scientists, we are continually looking at relationships. Is there a relationship between parents who read to their children at night and reading achievement? Yes, there is. We would not have known that had it not been for Mr. Pearson and Mr. Spearman coming up with statistics that tell us about relationships in nature. Mr. Spearman goes with which one? Which scale of measurement? Ordinal. And Pearson goes with which 2? Ratio. Why isn't there one for nominal?
It's the lowest thing.
It's the lowest, and we shouldn't use what with it? Math. We don't have one with nominal because this is math, right? Right? So this is letting us know that there are statistics out there that help us determine relationships with variables, and those are called correlation coefficients. Correlation coefficients are the coefficients, it's either a Spearman or a Pearson, that lets us look at relationships. Anytime you have 2 or more variables, you can determine if those variables have a relationship or not. So you need to know what a variable is. A variable is anything that what? Varies, anything that varies. In this class, and I will tell you right now, there's only women in this class. In this class, could I look and see if there was a relationship between sex and GPA in this class? No, because everyone's female in this class. It doesn't vary. It is what we call constant. A constant's the opposite. A constant is anything that doesn't. Your sex in this class is a constant. But could I look at whether you are a sophomore or a junior? Do I have both in this class, sophomore or a junior or senior, and whether that relates to your grade in this class? Yes. Because I have different classifications, that varies. And what about GPA? Does everyone have the same GPA? No, so that's going to vary. So anytime you have anything that varies, you can determine whether there's a relationship or not. We do want to be careful. We can't measure that with constants. Sometimes the media will try to confuse us with that. What if everyone in this class studied and everyone in this class earned an A? Could I say that studying has a relationship with, is related to your grade? Why or why not? No, could not. Correct. Because if everyone studied, was that a constant or a variable? Constant. If everyone earned an A, was that a constant or a variable? Constant. If I really wanted to know if those two things were related, I would have to have some people say, hey, I'm going to assign you to no studying group, and you are going to be in the group that only studies 1 hour a week, and you're going to be in the group that studies 5 hours a week, and we're going to see if studying is related to the grades. And if I had differences in grades, then I could determine if there was a relationship. So even though it can make sense, everyone studied, everyone got an A, I don't know if those two things are related or not, because I could also say, well, everyone came to class wearing clothes. Does that earn an A in the class? Well, obviously it doesn't. Everyone in the class drank milk growing up. Does that earn an A? So just because everyone did the same thing doesn't mean it has an effect. We would have to vary the variable to know. Yes?
So would you use, or using the studying, would you use like a variable, or what is considered a variable? Like if you had certain people study a certain way, like not just the 1 hour, but like say you made note cards, you just watch the PowerPoint and...
Absolutely. If you wanted to do a research study to see if the way you studied was related to a test grade, then you could vary how people studied. Absolutely. So anytime there's something that varies, that'll be a lovely study. Let's do it. All right, let's look at the next. Correlation coefficients are interpreted, this is nice, exactly the same. So whether it's a Pearson or a Spearman, a 1 is interpreted as a perfect positive relationship. So you don't have to learn two different ways. If it's correlation coefficient, a 1 is a perfect positive relationship. So what is a negative 1? Perfect negative relationship. A 0 represents no relationship. So do you think you'll have correlation coefficients that are above 1, that are higher than 1? No, you're correct. Why? You can't do better than perfect. Actually, I had a student say, my mom says you can't, but you can't. Right? Do you think you can be lower than negative 1? No, because negative 1 is also what? Perfect. What is that telling us? That the further away we get from 0, the stronger or the weaker the relationship. What do you think? The further away we get from 0. 0 means no relationship. The stronger, and the closer we get to 0, the weaker. Correct. So when we look at halfway in the middle here, they're not quite sure what to call it. So they'll call that a moderate relationship. And what number would go between 0 and 1? 0.5. So they'll call a 0.5 a moderate relationship. And they'll call a negative 0.5 a guess what? Moderate relationship. Anything above 0.5, what would they consider? Strong or weak? Strong, yes. Above 0.5 is strong. If it's below 0.5, weak. I'm hearing both. Below 0.5, strong or weak?
If it's between 0 and 0.5, weak.
Here and here, between 0.5 and 0.
Weak.
Weak relationship, yes. Okay, what about here? Strong. Between negative 0.5 and negative 1, because negative 1 is just as perfect as 1. It's just as strong as 1. Okay? A strong relationship. And then between negative 0.5 and 0, weak relationship. And again, because 0.5 and negative 0.5 is just as close to perfection as it is to nothing, they'll say a moderate relationship exists between variable 1 and variable 0.5 and negative 0.5, right? Yes. Cool? Questions? Before we talk about signs, I'm going to ask you a couple questions. What relationship is stronger, 0.8 or 0.9? 0.9. Why? It's closer to perfection. Exactly. The closer you are to 1 or negative 1, the closer you are to perfection and the stronger the relationship is. So this one is the stronger one. Right? What if I do that? Which one is stronger?
Negative 9. Negative 9.
Negative 9 is on the floor. Why is negative 9 on the floor?
Because it's closer to perfection.
It's closer to perfection, right? Negative 0.9 is closer to negative 1 than negative 0.8, right? Question? Right? On the number line? Yep. All right, now I'm going to be real tricky. Which one is stronger?
0.9.
Plus 0.9 or negative 0.8?
Plus 0.9.
Plus 0.9 is still so far. This has been the answer all 3 times. 0.9 was stronger, negative 0.9 is stronger, and 0.9 is stronger still because it's closer to what?
Perfection.
Perfection. Well, what if I changed it? I made this the positive and that the negative. Now which one is stronger?
Negative 0.9.
Negative 0.9. Cool. Now I'm really going to try to trick you. 0.8 and negative 0.8, which one is stronger?
They're the same.
They're the same strength, exactly. The same strength. They're just as close to perfection. So it doesn't matter if it's negative or positive with the strength. Bless you. The stronger it is, the further away it is from 0 in either direction. Cool? So what does that negative and positive mean? If we have a positive correlation, we call that a direct relationship. And that means as one variable varies, the other variable varies in the same direction. Because again, we have to have 2 or more variables, right? And we're seeing if they're related. Let's look at an example of what I mean. Do you agree that GPA is a variable? Why or why not?
They are.
Yes. GPA is a variable. Clearly, one student's GPA can vary to the next. Even a single student's GPA can vary from semester to semester, right? Yeah. What about how many hours you study? Is that a constant or a variable? Variable. So can I determine if these 2 things are related? Yes. Let's say that I do, and I get a positive 0.9. So describe that relationship, strong or weak? It's a strong relationship. And now we can call it a strong direct relationship. a strong direct relationship because it's a positive number. So what that means is, as GPA increases, because GPA is a variable and it varies, as GPA increases, guess what happens to the variable hour study? It increases. As GPA decreases, what happens to this variable? It decreases. What I mean by that, if I were to line all the students up by their GPA, starting with the low GPAs, and medium, all the way to the highest GPA, we are in a line. And I interviewed each one in the line. How many hours did you study last week? Went all the way down the line. From lowest GPA to highest GPA, what would I hear as I went down the line? That number would get higher or lower? Higher. It would tend to get higher if I have a 0.9 relationship. That means I saw that as one variable increased down the line, the other one also increased down the line. Or if I started with the highest and went backwards, what would happen? From highest to lowest, I would hear the numbers go down. As GPA decreased, our study also decreased. And that's what makes it a direct relationship. Questions there? GPA increases, our study increases. GPA decreases, our study decreases. If I want to predict then what a negative relationship means? That's right. One goes up, the other goes down maybe. Let's see. Let's see if that hypothesis is correct. A negative relationship is called inverse. I wish it was indirect. Don't get confused on the test. It's not direct and indirect. It's direct and inverse. And it does mean as one variable varies, the other varies in the opposite direction. Do you agree that hours watching TV would be a variable? Mm-hmm. So let's say that we determine if there's a relationship between GPA and hours watching TV, and we get a negative 0.8. Describe that relationship. Strong inverse. Strong inverse. Brilliant. I see some A's on the horizon. All right. So what does that mean? As GPA increases, what do we see happening to hours watching TV? Decreases. As GPA decreases, hours watching TV increases. Right? Any questions on the difference between inverse and direct? And again, it doesn't matter if it's a plus 0.8 or a negative 0.8 for the strength. They're just as strong. Just as strong. One is just direct and one is inverse. Lastly, I want to emphasize that correlation coefficients cannot be research that gives evidence for cause and effect. This type of research only tells us that in the environment, there's a relationship that exists. But if we want to determine whether it's cause and effect, we have to do different type of research. That's not this type. I want to give you an example. Because it sure does make sense. If there's a relationship between hours studied and GPA, it would seem naturally to think, well, doesn't that mean studying causes higher GPA? It may or may not. We have to do a different type of research. Because correlation coefficients only tell us about relationships. There is an almost perfect relationship. It's like 0.999, perfect direct relationship between foot size and reading achievement. If you know the answer, don't tell. So our brain's like, why would foot size cause you to read better? It doesn't. Just because a relationship exists does not mean it's cause and effect. Think about who has little feet. Oh, right. How big are babies' feet? Tiny. Can they read? No. They get older. They get in kindergarten, first grade, and they start learning how to do what? Read as their feet get what? Bigger. And when we're adult, we usually can read as well as we're going to read, and our foot's as big as it's going to be. So therefore, this bizarre relationship develops between foot size and reading achievement. The bigger the foot, the better you can read. The smaller the foot, the less able you are to read. And it has nothing to do with foot size causing you to be able to read better. The variable that's causing all this is maturation. Maturation causes your feet to get better. Maturation causes you to be able to read. When your brain, develops that reading readiness when you mature. So relationships like this can exist in the environment that have nothing to do with cause and effect. It takes different type of research to do that. So what we'll look at Thursday is what type of research can tell us about cause and effect, so I'm never confused again by the media. The media tries to confuse you with this, and I'll give you some examples. And then we're going to apply this knowledge that we know about the correlation coefficient to assessment. We'll do that on Thursday. Any questions before we start administering our tests? Thank you.